Assalamualaikum. Hi everyone. So this is a video on Chapter 7 Ionic Equilibria. In this video, we're going to discuss the subtopic 7.1 Acid and Bases, and at the end of this lesson, you should be able to first write the Henderson-Hasselbalch equation for a given buffer solution and then calculate the pH of buffer solution using the Henderson-Hasselbalch equation before and after the addition of strong acid or base. So, let's start by looking at what is the Henderson-Hasselbalch equation. So, Henderson-Hasselbalch equation is the equation used to calculate the pH of a buffer system. So, as you remember, we have two different type of buffer. Kita ada yang pertama acidic buffer dan kita ada kemudian yang kedua adalah basic buffer. And then as we have discussed previously, okay, what is a buffer solution? Okay, so buffer solution is any solution that can maintain its pH when a small amount of a strong acid or a strong base is added to the system. Okay, jadi macam mana kita nak tunjukkan yang kita punya buffer system boleh maintain its pH? So, we're going to focus on calculating the pH of the buffer system after the addition and after the addition of the strong acid or the strong base. Okay, kita akan tengok satu persatu equation, the Henderson-Hasselbalch equation for acidic buffer, and then kita akan tengok pula untuk basic buffer. So please be remember that for each buffer system, it will have a different equation. Sebab apa? Sebab apa yang kita masukkan ke dalam kita punya buffer, okay, the solution we use to make up the buffer system are different. So kita start dengan acidic buffer solution dahulu. Okay, so as you can remember, okay, like we have discussed earlier, macam mana acidic buffer dihasilkan? Acidic buffer is formed when we add into the system our weak acid, okay, and then kita tambah dengan kita punya conjugate, okay, conjugate base salt, okay, the conjugate base of the weak acid. Okay, now, so apa yang kita ada dekat sini adalah, okay, so for any weak acid HA, the dissociation equation and Ka expression is as given here. Okay, so this is the dissociation equation, this is the Ka expression. So from this Ka expression, kita rearrange the equation. So we rearrange the equation, we get concentration H2O plus equals to Ka times concentration of HA over A minus. Kita susun dekat sini. Kita letak H2O plus dekat sebelah kiri. Okay, now, so by applying negative log on both sides, okay, kita akan dapat kita punya Henderson-Hasselbalch equation dekat sini. Okay, yang mana kita letak negative log H plus, kita dapat pH. So the Henderson-Hasselbalch equation for the acidic buffer solution is pH equals to pKa time plus log concentration of A minus over concentration of HA. Yang mana A minus is the concentration of the salt or the conjugate base, and concentration of HA dekat sini adalah concentration of the weak acid. Okay, so generally, okay, inilah kita punya equation is samalah macam yang dekat atas ni. Okay, now, untuk kita kira, okay, at first the pH of the system, so awak kena ingat balik, okay, bila kita cerita tentang buffer, okay, yang mana we have over here a very high concentration of a weak acid and also very high concentration of a conjugate base salt. So, nilai yang kita akan masukkan dekat sini untuk conjugate base salt adalah the concentration of the salt solution. Okay, yang mana whatever salt solution yang kita ada, the concentration, all the salt will dissociate into the conjugate base. So, concentration dia akan samalah. Okay, kemudian untuk weak acid pula, okay, as we know, a weak acid will dissociate slightly in water. Okay, so bila dia dissociate slightly, concentration dia tak akan berubah banyak sebab yang berubah sikit saja, almost insignificant. Okay, so kita boleh assume that the concentration of the weak acid yang kita akan masukkan dekat sini, kita akan gantikan dengan nilai concentration at initial. Okay, so please bear in mind, you need to memorize this equation. Okay, so the Henderson-Hasselbalch equation for the acidic buffer is pH equals to pKa plus log, okay, ini ada kurungan dekat sini, okay, log concentration of the conjugate base over concentration of weak acid. Okay, why do I emphasize this? Because like I mentioned just now, different buffer system will have different equation. So, macam mana awak nak tahu equation mana yang awak akan gunakan? Bila kita cerita tentang acidic buffer, acid mesti ada weak acid. So, bila ada weak acid, okay, mesti ada Ka. Okay, dan sebab kita ada acid dekat sini, kita akan ada H+. So, H+, kita akan ada pH. Okay, so let's take a look on the basic buffer solution and you can see clearer, okay, what I meant just now. Okay, kita tengok pula kepada basic buffer solution. So, before we look at the equation, okay, so ingat balik, untuk hasilkan a basic buffer solution, so apa yang kita akan gabungkan dekat sini? Okay, so inside a beaker, we're going to add a weak base. Okay, so a weak base with it conjugate acid salt. Okay, so kita akan campurkan these two solution and then kita akan dapatlah kita punya buffer system. Okay, so let's take a look. So, for any weak base, okay, diwakilkan sebagai B, the dissociation equation and the Kb expression are given as follows. So, this is the dissociation of the weak base. Weak base tambah water dapat dia punya conjugate acid dan juga OH-. And this is the Kb expression. So, this is very important. Apa yang awak kena nampak dekat sini adalah, since this is a basic buffer solution which have a weak base. So, bila ada weak base, it's a base. So, OH- yang akan muncul dekat dalam kita punya equation. So, when we rearrange the equation, kita letak dia macam ni. OH-, concentration of OH- equals to Kb times concentration of the weak base over concentration of the conjugate acid. Okay, so again, by applying negative log on both sides, okay, kita rearrange balik semula equation kita. Negative log OH- is equal to the POH. Negative log Kb, kita substitute dia sebagai Kb, dan negative log concentration of B over BH. Okay, so negatif ni kita tukar jadi tanda positif. Macam mana cara dia? 1 over. So, inilah equation yang kita dapat dekat sini. So, this is the equation that you need to memorize. Okay, but in general, okay, apa yang kita akan ada dekat sini adalah, okay, untuk a basic buffer solution, instead of calculating pH, kita akan kira POH terlebih dahulu. Again, sebab apa? So, as you can see, since we are dealing with a weak base, so kita akan ada nilai Kb. Dan, since it's a base itself, it will dissociate and form OH-. Okay, yang mana kalau ada OH-, kita kena kira POH terlebih dahulu. So, be very clear about this. When you have an acidic buffer, equation yang awak akan guna adalah pH equals to pKa plus log concentration of conjugate base over weak acid. And if you have a basic buffer solution, the equation, the Henderson-Hasselbalch equation that you're going to use is POH equals to pKb plus log concentration of conjugate acid over concentration of a weak base. Again, dekat sini akan ada kurungan. Okay, log for everything that you have over here. So, to find the pH, okay, later awak akan gunakan this equation lah. pH equals to POH equals pH plus POH equals to 14. Okay. Now, let's take a look on some example to calculate the pH of the buffer solution. Okay, calculate pH of the buffer solution and then kira pH initial of a buffer solution and then what happen when we add a small amount of strong acid or strong base. So, again from this calculation, awak akan nampak dengan lagi clear macam mana cara buffer system maintain pH dia bila small amount of strong acid or strong base is added. So, kita akan bermula dengan acidic buffer terlebih dahulu. So, the example question for an acidic buffer. So, kita ada dua soalan dekat sini. Kita ada soalan A dan kita ada soalan B. Okay, so let's take a look on question A first. So, question A, it says here, calculate the pH of a buffer system containing 1.0 molar CH3COOH and 1.0 molar CH3COONA. And given here is the Ka value for CH3COOH, which is, this is our ethanoic acid. Okay. Jadi dekat sini, apa yang awak kena buat adalah, okay, kita highlightkan maklumat yang kita ada. So, the information that we have is, okay, we have a buffer system. Okay, so dekat sini, kita ada buffer system. Okay, so buffer system kita contains 1 molar of CH3COOH and 1 molar of CH3COONA. So, once you get a question, the thing that you need to do is, okay, identify, ada buffer system ke tak? So, as you can see over here, kita ada apa tadi? Kita tambah dekat sini, okay, we add into the system. Okay, ke dalam sistem dekat sini, ke dalam beaker kita. Okay, kejap. Okay, inside the beaker, we add CH3COOH dan CH3COONA. So, identify. So, ethanoic acid, okay, ada Ka dekat sini, meaning this is a weak acid. Dan kita ada dia punya conjugate base dekat sini. So, meaning dekat sini apa yang kita ada sebenarnya adalah we have over here, okay, an acidic buffer. Daripada soalan ni, awak tahu kita tengah buat acidic buffer sebab saya dah labelkan. But if in exam, the question maybe will not mention, okay, either it's acidic or basic. Dia just kata a buffer solution contains certain. Okay, so awak kena identify lah. Cara nak identify macam mana? The easiest way is look for Ka or Kb. So if you have a Ka value, okay, so most probably, okay, you will have an acidic buffer. Kalau awak ada Kb, so awak akan ada basic buffer. Okay, so ingat, bila kita cerita tentang buffer system, we need to identify which part of the solution, okay, maksudnya antara solution dekat sini kan kita masukkan dua tadi, we need to identify which one is the acid component and which one is the basic component. Ingat, that is the most important part of a buffer. Buffer system mesti ada acidic component, mesti ada basic component. Fungsi dia untuk apa? To neutralize the incoming strong acid and strong bases. Okay, so from the information we have, okay, so our acidic component is the weak acid and our basic component is the conjugate base. Okay, ingat, kita punya conjugate base bukannya garam. It's the conjugate base, bukannya CH3CONA. It's CH3COO minus. Ingat balik sebab apa? Okay, this is a salt. Okay, so garam akan dissociate completely kepada dia punya ion CH3COO minus and also Na plus. Okay, so please bear that in mind. Okay, now. So, saya akan keluarkan juga dekat sini okay, information yang kita ada tadi. So, we have the initial concentration. Okay, over here kita ada initial concentration of CH3COH and initial concentration of CH3COO minus. Okay, untuk initial concentration of the ethanoic acid, the concentration 1.0 dekat sini. Okay. And the concentration kiranya sebelum kita masukkan apa-apa acid dan base, okay, concentration dia akan remain constant lah. Sebab again, walaupun ada dissociation process occur for the acid, the dissociation is very slightly, sangat sikit, so dia tak mempengaruhi concentration asal. Okay, macam nampak almost tak ada. Macam tu. Kemudian concentration of CH3CO-, again, it will come from the salt solution. Okay, as I mentioned earlier, whatever salt we have over here, it will be completely dissociate into its ions. Okay, so ion dia tadi CH3CO- lah. So 1 molar sodium ethanoate salt solution. So dekat sini pun akan ada 1 molar CH3COO-. Okay, so again, apa yang kita nak cari dalam soalan ni? So in this question, we want to find the pH of the buffer system. So kita dah tentukan tadi, our buffer system is an acidic buffer. So bila acidic buffer, okay, awak dah tahu dah equation mana yang nak digunakan. We're going to use the Henderson-Hasselbalch equation for the acidic buffer. Okay, jadi by using the Henderson-Hasselbalch equation, okay, so this is the general equation. Okay, general equation kita adalah pH equals to pKa plus log concentration of conjugate base over concentration of a weak acid. Again, please put bracket over here so that awak tak akan miss out. Yang log ni adalah for the whole thing, bukannya untuk conjugate base sahaja ataupun bukannya untuk weak acid sahaja. Okay, kalau exam bertulis, okay, in the written exam, you need to substitute. Okay, apa yang awak kena substitute? Okay, what is the conjugate base? What is the weak acid? Okay, so substitute dengan species yang sebenar. So maksudnya, you will write down the equation macam ni. pH equals to pKa plus log concentration of CH3COO- over concentration of CH3COOH. Because markah dia tak bagi markah awak dekat sini. Markah dia dekat sini. Okay, dekat equation yang kita substitute dengan species yang betul. Okay, so once we have the equation, ingat target kita nak cari pH. So, kita check all the information. Do we have all the information? So, kita kena ada information Ka. Yes, we have Ka over here. We need to have the information on concentration of the conjugate base. Ada. Concentration of weak acid. Also ada. So, just substitute the value. And please bear in mind, when we have P maksudnya kita ada negative log. So, negative log Ka 1.8 times 10 to the power of negative 5 plus log 1 over 1. Okay, so last sekali, you will get the answer of the pH as 4.74. And please bear in mind, when we're talking about pH, dia cuma perlu kepada 2 decimal places sahaja. Okay, jangan lebih daripada 2. 2 sahaja. Okay, so that's question A. Now, let's take a look at example B. Okay, so what is the pH after the addition of 0.01 mole gaseous HCl into 1 liter of the solution? So, assume that the volume of the solution does not change when HCl is added. Okay, jadi contoh yang kita akan bincangkan sekarang ni adalah, so this is to show the action of buffer. Okay, macam mana a buffer system reacts to an incoming small amount of a strong acid or a strong base. Macam mana sistem kita neutralizekan the kiranya macam disturbance, okay, and then able to maintain its pH. Okay, so example yang saya akan tunjukkan dekat awak dekat sini. So this is an example of a question where the volume of the solution does not change. Okay, volume dia adalah constant. So, kalau melibatkan soalan yang volume of solution tidak berubah, so the calculation is simpler. Okay, where we only need to use whatever concentration is given to us. Okay, kita tak perlu nak kira concentration baru. Sebab apa? Volume tak berubah. Okay, now, we're going to start answering this question. Okay, kita highlightkan dulu information yang kita ada. So, information kita adalah addition of 0.01 mole gaseous HCl into 1 liter of the solution. So, pH tak berubah. Okay, jadi dekat sini, the disturbance that we have, kita tambah kepada sistem kita, we add a small amount, of strong acid. Okay, so ingat balik, strong acid akan dissociate completely into its ion. So, dia akan pecah dekat sini jadi H plus dengan Cl minus. So, apa efek H plus kepada sistem, kepada pH? When concentration of H plus increases, the pH value will become smaller. Sebab apa? It's becoming more acidic. Okay, tapi buffer, being a buffer, dia cuba untuk maintainkan dia punya pH. Okay, now. Jadi, kita akan jawab soalan ni. Okay, so, kita dah identify our disturbance over here is HCl. Okay, taklah disturbance tapi kiranya yang kita masukkan macam pengganggu jugalah. Okay, so, the addition of HCl, okay, after the addition of HCl, apa yang kita akan tahu, HCl will dissociate completely in water. Okay, jadi the dissociation, the complete dissociation of HCl will be like this. HCl tambah H2O to produce H3O plus and Cl minus. So, untuk dissociation of a strong acid, untuk buffer system, kita sentiasa tambah H2O dalam equation. Sebab kita nak dapatkan dekat sini H3O plus. Okay, now. So, as you can see over here, whatever concentration ataupun kita dekat sini kita ada number of mole. So, kita gunakan dulu number of mole. Okay, so whatever number of mole we have for the acid, okay, itulah number of mole of H3O plus yang kita akan hasilkan. Sebab apa? Complete dissociation, lepas tu dia 1:1 ratio. Okay, so kita nak kira pH. Again, disebabkan yang ini, okay, we have over here the acidic buffer system. So, bila acidic buffer system, ingat balik equation apa yang kita akan pakai. So, this equation, pH equals to pKa plus log concentration of our weak base over, conjugate base. Okay, conjugate base over weak acid. So, this is the equation. Cuma dekat sini, bila kita tambah, when we add HCl, akan berlaku perubahan pada kita punya concentration of the conjugate base and the concentration of the weak acid. Confirm akan berlaku perubahan. Okay, kenapa berlaku perubahan? So, dekat sini, kita kira dulu. Okay, sorry. Kita kira dulu dekat sini the concentration of the H3O plus yang kita tambah ke dalam sistem, which is 0.01 mol per liter, ataupun kita boleh letak molar. 0.01 mol bagi volume 1 liter, so 0.01 mol per liter. Or you can substitute, awak boleh tulis juga sebagai molar over here. Okay, so this is the first one yang kita kena buat. Second, kira balik, okay, disturbance kita dalam bentuk concentration, sebab dalam table nanti kita akan gunakan concentration inside the initial change final table. Okay, now, okay, so ingat balik, bila kita ada H3O+, this H3O+ will be neutralized. Okay, So ingat balik dalam sistem kita, since it's an acidic buffer, dia akan ada acid component, okay, dan dia akan ada basic component. So our acidic component is the CH3COOH and the basic component is the conjugate base CH3COO-. So disebabkan kita tambah acid, okay, H3O+, siapa yang akan neutralkan dia? The basic component over here. So CH3COO- yang akan neutralizekan dia. So what you will do next is construct a table. Okay, sebelum construct table, kita tulis equation terlebih dahulu. So equation apa yang kita akan tulis? Okay, now this is the equation that you will write down, the neutralization equation. Okay, so saya highlightkan dekat sini. Okay, this is the equation that you need to write down. Okay, yang mana as you can see over here in this equation, H3O+ tambah dengan CH3CO-. So this is the H3O+ that comes from the HCl, the disturbance, and then dia dineutralkan oleh CH3COO-. So table yang kita akan tulis dekat sini, okay, you going to construct an initial, okay, initial, change, final table. Okay, dekat sini kita tak boleh nak gunakan initial dan final sahaja. Okay, sebab kita nak kena check kita punya change dekat sini. Okay, so initial concentration kita masukkan. So H3O+ tadi 0.01, CH3COO- sama macam yang asal 1.0, CH3COOH 1.0. Okay, now as for the change, okay, macam mana kita nak tahu berapa banyak yang kita nak kena tolak? Kan selama ni kalau ice table kita letak sebagai X. Sebab kita tak pasti berapa banyak kena tolak. Okay, atau berapa banyak kena tambah. Tapi untuk reaction of buffer dekat sini, kita tahu exactly berapa banyak yang kita nak tolak. Okay, macam mana kita tahu? Okay, target kita adalah we need to remove any concentration of H3O+ added. Jadi, kalau kita tambah ke dalam sistem 0.01, yang kita kena tolak pun adalah negatif 0.01 dah. Okay, so once H3O+ kita tolak 0.01 sebab target dia mesti kosong at the end, CH3COO- also a reactant akan jadi -0.01. Okay, dan the acid over here, CH3COH, akan tambah 0.01. Reactant akan berkurang, produk akan bertambah. So, daripada situ kita kira kita punya final concentration. So, untuk H3O+, 0.01 minus 0.01, so kosong lah, dah tak ada dekat sini. So, maksudnya, the disturbance is already neutralized ataupun eliminated. Okay, how about CH3COH? 1 tolak 0.01. So, as you can see over here, the concentration of the CH3CO- changes. Asal 1. Okay, tapi dah digunakan, so berkurang tinggal 0.09. Sama juga dengan kita punya weak acid. Starting we have 1.0 molar. Okay, but at the end of the reaction, we gain extra CH3COH yang mana concentration dia akan jadi 1.01. So, this will be kiranya yang dekat sini. Okay, saya guna pen. Okay, maksudnya dekat sini, this is the concentration yang kita akan gunakan untuk masuk balik ke dalam kita punya Henderson-Hasselbalch equation for the acidic buffer system. Okay, so ingat balik tadi, kita dah kira kita punya pH of the system. Okay, yang mana kita kira tadi pH solution kita adalah 4.74. Okay, so sepatutnya bila kita masukkan asid, asid ada kepekatan dia. So the concentration, the pH will change. Okay, tetapi disebabkan kita ada buffer system, the buffer system neutralize the H3O+. Dan so this is the best part, where you can see that the pH is maintained. Okay, maintain dekat sini sama ada the pH is still the same ataupun close to the initial pH. Okay, dia berbeza tapi perbezaan dia tak terlampau banyak. Plus minus 0.02 selalunya. Okay, so gantikan balik ke dalam kita punya equation. So sekarang ni equation kita concentration pH equals to pKa plus log concentration of CH3CO minus final. Final meaning it's from this one. Kita tak boleh dah guna yang asal tadi 1 dengan 1 sebab dia dah berubah concentration dia. Over concentration of the weak acid also final dekat sini. Okay. So substitute the value. So P adalah negative log. Okay. Substitute negative log 1.8 times 10 to the power of negative 5 plus log 0.09 over 1.01. Okay. And tekan calculator. So the pH of the new solution, okay, the pH of the buffer solution after the addition of H3O+, yay, it's still 4.74. Walaupun kita dah tambah strong acid, tapi pH kita masih lagi 4.74. Ingat balik sebab apa tadi? The buffer system neutralize the acid. Okay, so that's the example for the acidic buffer. Now, let's take a look on an example. Okay, for a basic buffer solution. Okay, macam mana calculation untuk basic buffer pula? So, these are the two questions for the basic buffer solution. So, let's take a look one by one. So, question A. Calculate the pH of the solution prepared by mixing 500 ml of 0.1 molar hydrazinium chloride and 2H5Cl with 500 ml of 0.2 molar hydrazine. Okay, so let me highlight the information that we have over here. So, as you can see, okay, kita ada dua solution dekat sini. First, kita ada 500 ml of 0.1 molar hydrazinium chloride and 2H5Cl. Kemudian kita ada 500 ml of 0.2 molar hydrazine solution. So, two different solution with dengan dua different concentration dan juga volume yang berbeza. Okay. So, apa yang saya nak awak nampak dekat sini? Okay, first, let's identify. Okay, what do we have a buffer system? Okay, jadi awak scribble sikit. Okay, lukis beaker dan tulis apa yang kita ada. Okay, so the thing that we have over here, okay, in the mixture is N2, okay, N2H5Cl with N2H4. Okay, kita check. If it's an acidic buffer, so sepatutnya kita akan ada weak acid. Okay, kalau tadi weak acid, clue dia ada Ka. So if it's a basic buffer, kita mesti ada weak base. So macam mana kita nak identify do we have a weak base? Tengok maklumat. So we have Kb over here. So Kb untuk siapa? Untuk N2H4. Meaning N2H4 is the weak base. Okay, so awak label dekat sini siap-siap. So yang ni adalah weak base. So since N2H4 is the weak base, check the second solution. Does the second solution has the conjugate acid? So dekat sini N2H5Cl. So dia datang daripada mana? N2H5 plus dengan Cl minus. So yes, we have over here the conjugate acid. So bila kita ada conjugate acid, maksudnya apa? We have a buffer system kat sini. So buffer system kita adalah apa? Basic buffer. Okay, itu yang pertama. Yang seterusnya, apa yang kita akan buat adalah, okay, kita kena check concentration. So, untuk acidic buffer tadi, saya bagi awak contoh yang mana concentration adalah tetap. Okay, sebab apa? Volume tak diberikan. So, bila volume tak diberikan, kita assume that the concentration given is already for the volume of the mixture. Okay. Tapi dekat sini, for this question, okay, kita ada dua volume yang berbeza. 500 ml of the hydrazinium chloride, which is the conjugate acid salt. Okay, and then 500 ml of 0.2 molar hydrazine, okay, which is the weak base. Okay, jadi dekat sini, apa yang kita perlu buat adalah, okay, first, kita dah identify tadi kita punya weak acid, weak base and conjugate acid. So, saya akan tulis dulu, the acidic component is N2H5 and the basic component is N2H4. Okay, the next step adalah kita kena kira semula the concentration of the N2H5 dengan N2H4. Kenapa kita kena kira concentration semula? Because the volume changes. Asal setiap satu adalah 500. Tapi bila kita tambahkan dia, okay, when we add these two inside the beaker, what happen is volume becomes volume dia akan berubah lah. So dekat sini kita ada 500 tambah 500, so we have 1000 ml. So kita ada 1 liter solution. So when we have 1 liter solution, kita kena ada concentration yang baru. So we need to find the new concentration first. Okay, jadi setiap satu hydrazinium chloride and also hydrazine, we need to find the new concentration. But first, kita kena cari dulu dia punya number of mole, the initial number of mole. So, maklumat kita ada dekat sini, 500 ml of 0.1 hydrazinium chloride. Find the number of mole first. Macam nak cari number of mole? N equals to mv, okay, over 1000. Okay, so itu yang berlaku dekat sini. So, first, concentration number of mole of N2H5 initial, so this is the initial one, is 0.1 times 500 over 1000. So, kita dapat 0.05 mole. Kenapa kena cari number of mole? Because we want to find the new concentration. Okay, yang mana concentration yang baru, 0.05 bahagi dengan volume yang baru. So, kita dapatlah dekat sini, the concentration is 0.05 mole per liter. Or you can just simply tulis sebagai molar saja. So, kita dah buat untuk N2H5. Kita kena buat juga untuk kita punya weak base. So, again, the same step. Calculate the number of mole. So, 0.2 times 500 over 1000 dapat 0.1. Cari concentration yang baru, bahagikan dengan 1 liter. So, 0.01 mole per liter. Atau, again, kita boleh juga tulis dia sebagai molar. Okay. So, nanti, for the calculation of the pH, okay, calculation of the pH, concentration mana yang awak akan gunakan? You're going to use these two concentration, 0.05 molar dan juga 0.10 molar. Concentration yang diberikan dekat atas, this one and also this one, okay, kita tak guna dah. Okay, sebab apa? Kita dah ada concentration yang baru. So, yang ni saya pangkahkan dekat sini. So, kita tak guna. Saya pangkah supaya awak tak tengok dah kat situ. So, just focus on this one. Okay, so the next step, since tadi kita dah identify, we have a basic buffer solution. So, you need to choose the correct Henderson-Hasselbalch equation. So, that adalah basic buffer. So, the Henderson-Hasselbalch equation that we're going to use is the POH equals to PKB plus log concentration of the conjugate acid over concentration of the weak base. So, sekali lagi dekat sini ada kurungan. Okay, jadi substitute the real species. So, apa yang kita gunakan dekat dalam sistem? The conjugate acid, N2H5 plus dan the weak base N2H4. So, dia akan jadi begini. Okay, kurungan. So, what do we do next? Substitute the value. So, ingat kita kena cari pH terlebih dahulu sebab it's a basic solution. So, substitute KB kita dah ada dekat sini. P is negative log. So negative log 1.7 times 10 to the power of negative 6 plus log concentration of the conjugate acid 0.05 molar over concentration of the weak base 0.1 molar. Dan kita akan dapat dekat sini nilai pOH kita adalah 5.47. Again, kita nak apa tadi? We want to find the pH. Okay, kita baru ada pOH. So, apa kita kena buat kemudian? This equation. So, equation asal dia adalah pH tambah pOH sama dengan 14. So, yang kita nak adalah apa? Kita nak pH. So, just a bit of rearrangement. Okay. So, 14 tolak pOH, the value that we have over here. So, lastly, we have the pH of the solution as 8.53. Okay, settle. Okay, the next example, B. Calculate the new pH of the buffer after the addition of 2 ml of 0.2 molar sodium hydroxide. Again, okay, in this question, apa yang kita ada? Kita ada volume lagi. Okay, so ingat, setiap kali kita ada volume baru, maksudnya apa? When we have a new volume, kita kena ada concentration yang baru. Because the volume changes. Okay, volume change, concentration pun akan change. Okay, jadi dekat sini, what you need to see is, okay, apa yang kita tambah ke dalam kita punya buffer system. So, our buffer system is still the same. Okay, yang mana? Okay, kita punya buffer dekat sini, kita still ada basic buffer. Okay, yang mana tadi? Our basic buffer. Okay, inside the beaker, kita ada kita punya acidic component, which is the N2H5+, and the basic component adalah N2H4. Okay, so yang ni tadi. And then, sekarang ni apa yang berlaku adalah kita tambahkan kepada sistem kita NaOH. So, NaOH adalah a strong base. So, strong base dissociate in water akan bagi kita OH-. So, this OH- have the ability to change the pH of the solution. Okay, dia boleh menjadikan kita punya solution be more basic. But since we add the sodium hydroxide, a very small amount, into a buffer system, so buffer system will work wonders. Dia akan remove the OH- dekat sini. Okay, dan maintain its pH. Okay, now, so kita tengok kita punya jalan kerja satu persatu. So, disebabkan we have a new volume over here. So, total volume dalam ni akan berubah. Asal dia tadi kita ada 500 ml N2H5+, 500 ml N2H4. So, total tadi adalah 1 liter. Sekarang ni kita tambah lagi. So, we add another 2 ml. Okay, 2 ml, 0.02 liter dekat sini. We add another, apa kita kata? Another volume. Okay, jadi apa yang akan berlaku adalah we need to find the number of mole of the sodium hydroxide dulu, the initial number of mole. So, just buat 0.2 volume NVN equals to MV over 1000. 0.2 darab 2 bahagi 1000. So, kita dapat the initial number of mole sebagai 4 times 10 to the power of negative 4. Okay. So, as you can see over here. Okay, dia ni sebenarnya saya tersilap. Okay, dia bukannya 0.02. Tapi sebenarnya dia adalah 0.002 liter. Sebab apa? 2 mililiter sahaja. Okay. So, when we add 2 mils of sodium hydroxide, the total volume will change. So, kita kena kira lah dulu total volume yang baru. So, sebelum tu. Okay. sebelum kita kira total volume, kita kira dulu number of mole of OH minus yang kita tambah ke dalam sistem. So ingat tadi sodium hydroxide, after addition of sodium hydroxide, the sodium hydroxide will completely dissociate in water. So whatever number of mole we have initially, itulah number of mole of OH minus yang kita ada dekat sini. Okay. So once we have the number of mole of the OH minus, the real disturbance, apa yang kita akan buat sekarang adalah, okay, kita akan kira dulu the new concentration. Concentration siapa? Ketiga-tiga spesies yang kita tambah. Kita kena kira new concentration of OH minus. We need to calculate the new concentration of N2H5 and also the new concentration of N2H4. Okay. Untuk number of mole of N2H5, the N2H5 plus dengan N2H4, you don't have to calculate again. Number of mole tadi kita dah calculate dekat part A. So just use that number of mole. Number of mole dia masih belum berubah lagi. Okay. So our total volume right now 500 ml plus 500 ml plus another 2 ml is 1002 milliliter, which is 1.002 liter. Okay, daripada kita punya new volume, kita calculate the new concentration of each species. So concentration of OH minus, number of mole over volume. So 3.99 darab 10 negatif 4. Okay, dan kemudian the concentration of the two buffer species kat sini. So 0.05 divide by 1.002, so dapat 0.0499. So ingat, mesti ambil 4 decimal places. Okay, 4 or more, mesti ambil 4. Okay, sebab kalau kurang daripada 4 nanti dia jadi tak accurate. Okay, kemudian N2H4 0.1 over 1.002 equals to 0.0998 mole per liter. Okay, sampai sini kita dah kira kita punya concentration. Now, let's proceed to the next step. So, step seterusnya tadi adalah kita nak cari pH baru. Okay, so kita nak cari pH baru of the buffer system bila kita tambah NaOH. Yang mana kita tahu tadi, okay, akan tambah OH minus. So, cara macam mana? So, you need to identify OH minus akan dineutralizekan oleh siapa. So, as you know, okay, tadi kan kita ada kita ada acid component. Okay, N2H5 plus dan kita ada basic component N2H4. So, since yang kita tambah adalah base, so base will be neutralized by the acid component dekat sini. So maksudnya yang akan neutralizekan OH minus adalah N2H5. So we're going to start by writing down the equation, the neutralization equation, and also constructing our initial, change and final table. Dalam table kita akan gunakan concentration. Okay, sebab tu tadi kita dah cari concentration awal-awal. Okay, so the added OH minus from the base will be neutralized by N2H5 plus. So this will be the equation. So OH minus tambah N2H5 plus to produce N2H4 plus H2O liquid. Okay, jadi initial, change, final. So each species kat sini kecuali water tak ada perubahan, kita dashkan terus. So, there will be initial concentration. Okay, yang ni tadi yang kita dah kira sebelum ni. Okay, kita kira concentration pada volume yang baru. Initial concentration of OH minus, initial concentration of N2H5 plus, initial concentration of N2H4. Okay, kemudian change. Okay, so berapa banyak change yang kita nak letak? Okay, berapa nilai change dekat sini? So, again, nilai change bergantung kepada disturbance. So, our disturbance, okay, OH minus, nilai dia adalah 3.99. So, ingat target kita adalah we want to remove all added disturbance, all added hydroxide ion. Okay, jadi, nak tolak berapa? Tolak 3.99 darab 10 negatif 4. So, bila last kali nanti kita akan dapat kosong lah. Okay, jadi sesuaikan dengan semua. So, N2H5 is the reactant. Dia akan berkurang sebanyak 3.99 dan 10⁻⁴ sebab ratio 1:1. Kemudian N2H4 is the product. So, it will be produced. Tambah 3.99 dan 10⁻⁴ sebab ratio 1:1. Kalau ratio dia 1:2, awak darabkanlah. Okay, and finally, this will be the final concentration of our system. Dan concentration yang ada dekat sini yang kita akan gunakan semula untuk cari kita punya pH. Okay, so now, moment of truth, we want to find the pH. Again, disebabkan kita masih lagi berada dalam basic buffer system, so the Henderson-Hasselbalch equation that we're going to use is still the POH equals to PKB plus log conjugate acid over weak base. Masih lagi kita akan gunakan equation ni. Okey, dan sedikit peringatan, okay, kalau yang ni kita buat, kita tambah sodium hydroxide. Kalau saya tambah acid, okay, saya tambah H2O+ dekat sini. Equation untuk cari base masih takkan berubah. Equation untuk cari the Henderson-Hasselbalch equation kat sini will still the same. Equation ni kat sini berdasarkan apa buffer yang kita guna. Okey, bukannya berdasarkan apa yang kita tambah. What's the buffer? Sama juga tadi kalau acidic buffer, saya tambah strong base. Last kali nak cari pH, masih lagi gunakan pH equals to pKa plus log concentration of conjugate base over weak acid. Okay, so substitute balik. Okay, so this is the equation dan dekat sini mesti ada final. Okay, sebab kita kena ambil concentration last sekali. So as you can see over here, when the neutralization ended, okay, system dah neutralizekan OH-, there will be decrease in concentration of N2H5+, and also increase in the concentration of N2H4. Sebab tu kita kena letak dekat sini final, a new concentration after the reaction have finished. So just substitute the value. Okay, tekan calculator dengan sangat berhati-hati and you will get the pH. Kita dapat POH terlebih dahulu. 5.46 sebab kita kira POH. Once we get the POH, barulah kita kira kita punya pH. So, nak kira pH, 14 tolak POH, substitute. So, kita akan dapat kita punya pH sebagai 8.54. Okay, compare dengan initial pH kita tadi. So, our initial pH of the system adalah 8.53. Yang ni sebelum kita masukkan. So, as you can see over here, okay, even though the pH is not maintained, kiranya pH dia tak sama, berubah. Tapi perubahan dia adalah sangat sikit. So, kita nak katanya, our buffer system berjaya lah. Okay, it can maintain its pH the same ataupun almost similar to the initial pH. Okay, so this is our final answer. Okay, so that will be all for the calculation of acidic buffer and basic buffer solution and also its action. So if you have any problem, okay, do ask me anything. Okay, so that's all. Thank you for listening. I see you guys in the next video. Bye.